All right. Second page here, number 6. And the diagram below of angle DBC is 100. So D or BDC. So this is 100. Label it on your diagram. Angle A is 50. That's the one that's out here. And DCB or DBC is 30 over here. All right. And I want to know which of these is true. So if I'm trying to check obtuse, isosceles, scalene, what I really need to know is what are the angle measures. If I can tell you that first, then I'll be able to answer the question of whether it's a scalene, right, isosceles or not. So just pay attention to those. Okay, so first of all, if this is 8, if this is 100, well, we know two things. Number one, we know this is the exterior angle to the small triangle over here on the left. So if this is 100, this is going to be 50. Okay. We also know that if this is 100, the angle next door is going to be supplementary, so that has to be 80. Because remember, 180 minus 100, right? And then if you check it, right, 180, this sum is 130, so minus 130 doesn't give us 50. So that's where these numbers are going to come from. And then this is also 50 because it's really 130 taken away from 180. Okay? Now, what does that mean? Two things. Number one, there's 3 different triangles here, right? So if you focus on each one, ABD, ABD, is it obtuse? Well, this obtuse means one of the angles is bigger than 90. This one right here, you can tell these are all less than 90, so that's not true. This is actually an acute triangle. All right. ABC is isosceles. ABC, that's this big angle right here. You can see we have two 50-degree angles, which are congruent. So this is true. That is isosceles. Okay. Let's just keep going down the line now. Take a look at all of them. Is A, B, D equal to 80? Careful. That's this left side here, which is actually 50. Okay. And ABD is a scalene. We can tell that these two angles are equal. That's not true. This is isosceles. So we want choice 2. All right. Number 7 in the diagram below, L is parallel to M. QR is perpendicular to ST at R. Okay, so a couple things we know. We know this is parallel to this. We know we have a right angle there and technically on the other side. But we're really going to focus in on that guy. So it says that measure of angle 1 is 63. How do I find the measure of angle 2? Okay, keep in mind, we're looking for the parallel lines here, right? So across this parallel line and this parallel line, we got that Z coming in here. See the Z? So those are all alternate interior angles. So that means that this angle down here is also 63. All right? So now, if we look at this triangle right here, we have a 63 and a 90. So what's angle 2? So you can either use that these are complementary, which means they have to add a 90, because you see 90 degrees for this one, or if you add 63 and 90, right, you're going to get 153. And then we can just do 180 minus 153, okay? And this is going to be 27 degrees. So far, so good. Now, if I did 90 minus 63, okay, I'm also going to get 27. So either way is going to work. Just make sure you state the measure of angle 2 is equal to 27. All right. Number 8, the diagram shows below. So we have perpendicular here and on the other side, if we need it. We have EBD, EBD, and CBD, that these two angles are equal to one another, and ABE, which is this one, right, is 52 degrees. Okay. So what is the measure of angle D? So there's a couple things we can figure out. Right from the get-go, we can see we have a triangle here on the left. So I should be able to get the measure of angle A from that. So if you want to do the 90 plus 52 again, or just do 90 minus 52, this is going to be 38, and that's the measure of angle A. You can get it if you need it, so just be aware, okay? Really what we want to focus in on is the use of these 3 angles down here, adding to 180, making a straight line. And so what I really want to know is that if I call this x, because I don't know what it is, I'm also going to have to call this angle x, because they're equal. So essentially, we can build an equation here using these three, where we do x plus 52, or just 2x, right? Plus 52 is equal to 180. So if we solve, we move the 52 over, we combine both the x's into 2x, we subtract, we're going to get 128, and then we can divide out by 2, okay, and x is going to equal 64. So that's the measure of angle x here. So keep that in mind. Now, two ways to get angle D from here. We can either focus in on just this triangle right here. We got a 90-degree angle, so what's that? Or we can focus in on the really big triangle and the combination of these two angles. And then 38 plus this guy, angle D, should equal 180. So I'll leave that kind of up to you, which one you want to use. But if you just do 90, take away 64, all right, just know we're going to get 26 here. And then 52 plus 64 plus, we'll do 38 here, right? These three angles plus D should equal 180. So just be aware that's 14. And that's 12, 154, and then 180 minus 154. And there's our 26 again. So either way, the measure of angle D should equal 26. All right. Number 9, diagram below. We got a four-sided figure. That's what a quadrilateral is with this diagonal drawn in. Okay. We know that measure of angle A is 93. We know that this is 43 down here, ADB. We know C is 3x plus 5. We got 2x plus 6, x plus 19. What we want to know is whether or not AB is parallel to CD. We're not sure, but we want to figure it out. So if they are parallel, if this line was parallel to this line, the question is, what would be the same, right? Really, which angles should be congruent? So if we focus on this line and that line, we can follow the Z down, right? And we should show that this angle should be the same as x plus 19. Okay, so let's start by just looking at the two triangles, right? We got the one up here where we have 93 and 43. So really, if you put these two together, right, we're going to get 90 plus 40 is 130, so 136, okay? And then if we do 180 minus 136, that should leave us with 44 degrees. And so that's what this angle is right here, okay? Now the other thing is, if we look at just this triangle down here, we got the three angles that are adding to 180 and they all involve x. So I have to essentially solve this equation and say, what does x have to be in order to get these three angles to add up to 180? So 2x plus x plus 3x is 6x. And then we got the same deal, right? 6 plus 19, 25 plus another 5 is 30. And now I can solve. So minus 30 from both sides. 6x is equal to 150. Divide up by 6. And x is equal to 25. Now, if we take and plug 25 in, the question is this going to equal 44? And when we add them together, we will find that this is indeed equal 44 degrees. And so yes, right, AB is parallel to DC, okay? And we can write our statement we normally write, right? Two parallel lines cut by a transversal. The alternate interior are congruent. We're good to go. That's it. Okay. Good deal.